Yeah. Good morning, everyone, and sorry for the slight delay in getting set up. Welcome to PGConf 2024. I know you guys have been here for the last couple of days. I was not able to join due to other commitments, but I'm happy to be here today to talk to you about what Google is doing both in the Postgres space as well as how we are incorporating AI pretty much not only in our Postgres managed offerings, but also in the broader Google Cloud databases as well. By way of introduction, my name is Subhash Guddad, and I lead the databases and application practice for Google Cloud in APAC. I've been with Google for about 3.5 years. I was here last year as well, talking to you about our latest database at that point of time, AlloyDB. I'll touch a little bit upon that as well this year, but we'll talk a little more about what we are doing in the AI space with Google Cloud databases, right? But before we get into the AI aspect of it, I just wanted to give you, everybody, a quick sense of the types of databases that Google Cloud offers to our customers and partners, because as most of our customers are moving from on-premises to cloud-based databases, they come from a variety of sources, right? So they obviously use a lot of legacy databases like Oracle and SQL Server, plus they use a bunch of open source databases like MySQL and Postgres, as well as very, very popular databases like Redis, which is an in-memory store, as all of you are aware of as well, right? And then, of course, as customers move to the cloud, they're also looking at ways to adopt more cloud-native technologies. So what our customers have been asking us for is a variety of options that they can have available to them as they move to the cloud, so that they can pick and choose which is the best target for them for their existing databases. Many a times, if they're running, let's say, an Oracle or SQL Server database, it may be running a packaged application and not very easy to convert it into, let's say, a Postgres-compatible version. They want a lift and shift motion. So we have a solution called the Oracle Bare Metal solution, which lets you run the Oracle database exactly as you would run on-premises, for example. But if the customers are already running MySQL and Postgres and Redis, even SQL Server for that matter, on-premises, we offer managed services to get them to Google Cloud. And that service is called Cloud SQL. Cloud SQL is our managed relational database service. It is the oldest relational service we have within our portfolio, has been there for many years, and is one of the most popular services that we run, right? Now, apart from that, we obviously offer a managed service for Redis as well. We have a service called Memory Store for Redis, which basically gives you the ability to run very large Redis clusters. So if you want to run hundreds of nodes of Redis VMs or Redis environments, Memory Store for Redis does that for you. From a cloud-native database perspective, we have very unique and differentiated databases in our portfolio. Spanner is one of them, which I'll talk about a little bit in a bit. But Bigtable is our key value store. And this database is or the paper that we wrote for Bigtable is what HBase was built and developed on, right? So a lot of the work that was done in Google many years ago, a lot of that has found kind of its way into the open source as well, right? But so that's kind of where we are. And then the final database, the newest database in our portfolio is AlloyDB, which is a fully Postgres-compatible database where we have done a lot of enhancements in the kernel, in the storage layer, in terms of AI integration and so on, and I'll again delve into a little bit deeper into that. So this is kind of a high-level view of the Google Cloud database portfolio, but as you can see on the picture here, we have at least 3 databases that are Postgres-ready or Postgres-compatible, right? The first one is Cloud SQL. Cloud SQL is a 100% Postgres-compatible database, compatible to open source. AlloyDB also is 100% Postgres-compatible. Spanner, which is a cloud-native database, has a Postgres interface. We don't claim 100% compatibility, but for customers who need the familiarity of Postgres, the Postgres interface on Spanner does that for us, right? And I'll talk a little bit about that as well. So let me quickly delve into the 3 Postgres offerings that we have in Google Cloud, right? So the first database managed service that we have is Cloud SQL. Now, Cloud SQL is an interesting service in the sense that it supports 3 engines, right? And this is for customers who run multiple database engines and they want a common way of managing, monitoring, performance tuning, backing up, and creating DRs and read replicas and things like that. So if you have MySQL and Postgres and SQL Server, and you want a consistent way of managing and monitoring these databases, Cloud SQL is the best database service for that, because the user interface layer, the DBA layer, the management and monitoring layer remains the same across all of these 3 different engines. Now, what we have done with Cloud SQL as well is we offer 2 variants. One of that, which has been there for many years, called Enterprise Edition, which kind of gives you 99.95% availability and meets a large use case, requirements of a large number of use cases. Just last year, we enhanced Cloud SQL and introduced a variant called Enterprise Plus, which is higher performance, has better data protection and better security, and that gives our customers 4 nines of SLAs for Postgres, MySQL, and soon for SQL Server as well, right? So that's kind of one Postgres database that we have in our stable. The second one is AlloyDB and AlloyDB Omni. This is the latest database offering that we added. I think we went GA with AlloyDB in December 22, and we went GA with AlloyDB Omni in October 23, right? And AlloyDB is a reimagining of the Postgres database, the way the storage layer works in Postgres. We have completely transformed that by using very Google-specific technologies. I will not go into a lot of detail in the architecture. I did cover it last year, but if you do have questions, please visit our booth, and we are more than happy to take you through the architecture of AlloyDB per se and AlloyDB Omni as well. What we have done with AlloyDB is obviously also provide a 4 nines SLA for our customers, and one of the things when we built AlloyDB was we were targeting it primarily to go after the legacy databases like Oracle and SQL Server. The moment you do that, a lot of our customers said, we can't move to the cloud right away. Can you give us AlloyDB on premises? Or I am an AWS customer, I'm an Azure customer, I want to run it in AWS and Azure because all of my other infrastructure runs there. So we created AlloyDB Omni, which is basically the same AlloyDB that runs in Google Cloud, but in a downloadable format. So you can download AlloyDB Omni, run it on a laptop, you can run it on a GCE VM, on an EC2 VM, or you can run it on premises, and you get exactly the same functionality that you get with AlloyDB, right? So that's what AlloyDB Omni is. It's really meant for customers who want to run on-prem or in a hybrid environment and get the same capabilities that AlloyDB offers in the cloud as well. And then finally, we have Spanner, which is our cloud-native database, which is a distributed database. It has global distributed scale. We use it internally for a lot of our applications. Basically, a lot of the billion user applications that all of you use, photos, YouTube, etc., use the Spanner under the covers. So what we have done is taken the same Spanner database and made it available for our customers as well. What Spanner gives our customers is 5 nines of availability. So literally 0 RPO, 0 RTO for any type of failure, including planned changes like schema changes and so on. So it's an extremely, extremely powerful database that a lot of our customers use for very, very high throughput and high availability requirements. Again, we can go into more details on Spanner if you kind of visit us at the booth later on. Just a little bit of deep dive on AlloyDB. What AlloyDB gives our customers is 3 or 4 things, right? First is, it is a fully Postgres compatible database. Like, let's start with that, right? So any application that is written in Postgres, open source Postgres, or any other variant of Postgres will run as is on AlloyDB. You don't have to change your code, nothing changes. What we have done is we have reimagined the storage layer. We use Google's own storage technology called Colossus that helps us scale the storage layer in a virtually infinite fashion and kind of offloads a lot of the I/O processing from the compute tier into the storage layer, right? So we have a bunch of log processing servers that run at the storage tier. So storage is a little bit intelligent, understands Postgres PostgreSQL constructs, and takes away some of the load from the compute tier. That's kind of one enhancement. The second enhancement we have done is we have added analytical capability to Postgres through something we call the columnar engine. So columnar engine is very similar to, if people have worked with Oracle database in memory, where when you run an analytical query, the data is residing in the RAM of the system, and your query gets satisfied from there. Your scans are faster, your aggregations are faster, and so on. So that's an enhancement. Those are just 2 enhancements that I quickly want to touch on. Because of these 2 enhancements, what AlloyDB offers to our customers is up to 4 times faster performance for transactional workloads as compared to open source Postgres, and up to 100 times faster performance for analytical queries. So that's kind of the big performance gains that we see with AlloyDB. In terms of scalability, the biggest AlloyDB shape we support currently is 128 vCPUs. We just announced that last week. And we can support up to 20 read replicas of a primary instance, which basically means that the read replica scaling can go beyond 2500 vCPU. So it's a hugely scalable system, and it is needed when we compete with the likes of Oracle and SQL Server, because some of those systems are pretty humongous, so we need an equivalent configuration to kind of meet those requirements as well. So that's kind of where we are with AlloyDB in terms of scale, in terms of performance, and the final piece we have added to AlloyDB is what we call autopilot capabilities, where we have automated a lot of the mundane and the difficult tasks that Postgres users have to deal with. Auto vacuuming, I know it's been there, but we have enhanced that with AlloyDB to make it even more intelligent. We have added things like Index Advisor, so that as you run your workload, AlloyDB will kind of help you to decide which indexes need to be created, and then helps you improve performance as well. Just two examples of autopilot capabilities in AlloyDB. We've also integrated a bunch of AI stuff in AlloyDB, and I will talk about that in a little more detail in the next few slides, right? And then, just like AlloyDB, AlloyDB Omni is the equivalent for AlloyDB, runs on premises. The only difference is that the storage tier that's available in Google Cloud is not available to us on premises. So the storage enhancements are not available in Omni, but anything at the compute tier, the kernel improvements, the columnar engine, the autopilot capabilities, index advisors, AI integration, all of that is available in Omni except the storage tier, right? So that's the only difference between the two. For developers, AlloyDB Omni is free. You can just download, play with it. It runs in a container, so just runs in a Docker container, and you can just download and play with that, right? So Omni is kind of useful for a lot of our customers who want to play with AlloyDB first, and then kind of decide whether they want to go to the cloud service. So that's a quick view of the Google Cloud databases and a little bit around what the Postgres variants are that we offer. Now, as you saw in the title of this talk, we talked about AI everywhere with Google Cloud Database. What do I mean by that, right? What does AI have to do with databases at all, right? So that's kind of where I wanted to spend a little bit of time today. So if you look at the traditional AI lifecycle, if there are data scientists in the room, they will identify with this, is there is, before this whole LLM and Gen AI era, whenever people talked about building models, there was a lot of effort needed to collect the data, kind of transform the data, munge the data, various terms get used there, then kind of train the model, obviously get the data, create a training set, build the model, test it, and then finally deploy it, and then measure the performance of the model, right? And just to do all of these activities, you needed a bunch of different tools. What I'm showing there is the Google Cloud services that get used to do the entire AI lifecycle, right? It's exactly the same on any other cloud or any other on-premises environment as well. But there's a lot of work, as you can see, to just build, train a model, deploy it, and then monitor it, right? Which is great. That was how it was 2 years ago, right? Now, what we did when we launched AlloyDB is, if customers have already built a model, they could take that model and deploy it in a Google Cloud service called Vertex AI, which then serves the model to anybody who wants to do inferencing of that model, right? So call the model and get a response from the model. That's what inferencing is. So what we did with AlloyDB was we integrated AlloyDB as well as Spanner with Vertex AI, so that as you do a transaction on AlloyDB, you can immediately call out to that Vertex AI model and get a response back. Example on the screen here is about a fraudulent transaction, right? You do a transaction for buying something. Before the transaction is accepted, you can call an AI model and say, is this a fraudulent transaction or not? And based on the data in that transaction, the model would say fraudulent or non-fraudulent, and your transaction will go through. That's a simple example of how we have integrated an existing pre-trained model and integrated it with AlloyDB and Spanner, and we'll add it to other databases as well. So this is how we did the traditional way of the traditional AI. A model is built, and we can use that in a database through the integrations that we have built in AlloyDB, right? But that's kind of seems to think of the past completely, right? November of 2022, the world changed, right? When all of, obviously LLMs were there before, but with ChatGPT launching and LLMs coming to the forefront, the entire industry from an AI perspective has changed, right? No longer do you need to have data scientist skills to be called an AI user or an AI developer, right? And that's really what happened with this whole Gen AI paradigm shift. what Gen AI really opened up was a completely new world for a consumer, an end user, a developer, as well as a business user to create content without having to worry about how do I train a new model, how do I accumulate data, how do I munch the data, and then build a new model, right? So what Gen AI basically did was gave users pre-trained models, which are called LLMs, or large language models, which can then be conversed with, right? So ChatGPT, Google's Gemini are conversational agents that can talk to an LLM model and can give you answers based on the training that that model had gone through. And the way the models had been trained is corpus of text from various sources, billions of parameters being used for training the model and so on, right? And that's really where Gen AI has started opening up a completely whole new set of user experiences. So what we call this the post-training era, right? Because users or data scientists don't really need to train models anymore. There are pre-trained models available, and Google offers them, Microsoft offers them. There are open source models available in the public domain, which have already been trained by someone else for you, and you just become a user to that model. And that's why we call it a post-training era, which basically means that you do not need to have deep learning skills. You do not need to be a data scientist to work with AI and to kind of interact with these models as well, right? So that's kind of where LLMs have got us today because of all the effort that has been done by somebody else to build the model, train the model, and make it available for you, right? It's great, right? So everybody thinks LLMs are the best thing to happen. But obviously, LLMs by themselves are not enough, right? If you look at an LLM, they have been trained and frozen at a point in time. So if you ask it a question which it was not trained on, it potentially could give you a wrong answer, right? And many of you have heard the term called hallucination. So LLMs hallucinate because they will not say that I don't know the answer to it unless they've been trained in that manner. They will just spit out an answer very confidently, and you may think is the right answer, right? So that's called hallucination. That's number one. Second is context, right? The LLM will tell you something, but if it's not provided enough context, it will not be able to give you the right answer. Let me give you an example. If I ask the LLM a question, what should I do today? It will give me an answer. It will say, go read a book, right? Go take a walk, go meet friends, right? Something of that kind. Because it did not know who was asking the question, it did not know where the question was being asked for, so the context of the question was not available. But now, if I tell the LLM, I am at the beach with my daughter, I cannot do kite surfing or I cannot do wing gliding, give me, tell me what to do, right? The moment I give that additional context, the LLM now knows that I'm at the beach with a 4-year-old girl, so it will basically say, hey, go build a sandcastle with your daughter, right? Or do something of that kind. So that context really helps to build the response for the LLM, right? And that's really where databases come into play. So databases bridge the gap between LLMs and provide them that additional context and the most current information so that the LLMs can respond in the best possible manner. And this is a pattern that is called RAG, Retrieval Augmented Generation, where you retrieve some data from the database, you augment the prompt to the LLM, and send that prompt to the LLM, and then it generates a much more accurate and a contextual response, right? So that's really what databases are do very well. And the core technology in databases that helps to do these comparisons and searches is a technology called vectors or vector embeddings, which have been there for many years, but they have now become very popular in the LLM era. So what is a vector? A vector is nothing but a string of numbers or an array of numbers which represents the semantic meaning of an image, a video, a text, and so on, and you can store that as an array of numbers in a database, right? And with Postgres, the Postgres community launched PG Vector more than a year ago, where Postgres now gets converted into a vector database because the ability to store, index, and retrieve data based on vector comparisons is available in Postgres databases, right? There are a lot of these dedicated vector databases out there, Pinecone and VV8 and so on, which a lot of people use. And we have seen this play out in the past. Whenever a new technology comes in, there's a bunch of startups who come and say, Here's a dedicated way of doing it. Object databases, XML databases come to mind, right? JSON databases. But over a period of time, relational databases like Postgres have incorporated those technologies into Postgres and other databases, which makes it easier for users to consume these technologies because they can not only use vectors, they can also combine that with data from their operational data store. So that's really where vector embeddings come in. And with Google Cloud, with both Cloud SQL and Postgres, Cloud SQL, Postgres, and LIDB, we introduced PG Vector extension last year, and it's been extremely popular with the users. This is an example of what a similarity search looks like with PG Vector. If you look at the red box there, that's how you do a vector comparison, right? So the question which was being asked is, what kind of fruit trees grow well here? Right? That's the question the user asked, right? There's no context to it. But because this database has additional information about maybe who the user is, where the user is based out of, which store the user has connected to, the query can be enhanced with things like store ID, inventory levels, and so on, and then the LLM gives out a much more accurate answer based on that question, right? This is an example of RAG, so that you know what it is. Okay. What we've done with LOIDB is enhanced PG Vector, made it 10 times faster than the open source version, as well as 4 times a bigger address space as well. So for customers who want to build large-scale applications with AI, LRDB AI is the way to go, right? Now, so LRDB, Postgres databases, PG Vector, great, we support all of that. But what we have also done that is take it everywhere, right? That's the whole intent of this talk. With LRDB Omni, all of the data, technologies I talked about, PG Vector, the performance of that is available with us in Omni as well, so that if you run Omni in on-premise environment, you get all of those AI capabilities available to you with LRDB Omni as well. And just hot off the press, we just announced support for vectors in pretty much every Google Cloud database just last night, right? We now support vectors with MySQL, Cloud SQL, we support it with Spanner, we support it with Redis, and LRDB AI is generally available as well. Just last night, we just made these announcements so that AI is now available in all of Google Cloud databases so that customers don't have to worry about, hey, I'm a MySQL user, I cannot play in this LLM space. So that's what we've done, right? So that's a quick announcement there. Just a couple of slides more. All this while I was talking about how do you build applications using AI, right? But developers are not the only persona that works with databases, right? There are SREs, there are DevOps people, there are DBAs, there are business users who want to know what's happening in the database fleet, right? So what we have done in Google Cloud is have started to address the requirements of those people as well from an AI perspective. We launched a branding called Duet AI in Google Cloud, which is basically an always-on AI collaborator for end users. So with Duet AI for databases, we are going to do 3 things. And this is in preview currently. The first is we are going to provide a conversational interface for the different people who work with databases and database estates. Second is we are going to offer developers and DBAs a way to interact with the database, create queries in natural language. And the third thing is, in migrations, we are going to use Duet AI to convert code from Oracle, PL SQL, to PL, PGSQL, and other kind of variants depending on the source and destination, right? So if we look at a quick example of this, in this conversational assistant, it's very small, but the question which is getting asked there is, how many of my databases do not have backups enabled? That's an English language question, and Duet AI is giving an answer saying, out of the 2850 databases, about 1634 databases do not have backups. The second question that is asked is, how many of these are production databases? And then it gives you an answer as well, right? Similarly, if you're a business user, you can ask a question, or if a CISO, you can ask a question is, which of my databases are exposed to security vulnerabilities? And it will give you an answer. So that's an example of a conversational assistant. In terms of completion of code, we will, if you look at the red line, it basically says, write a query for a particular table, and it kind of creates the query for you. This is available in preview. And just finally, like I said, we will help you with database migrations, where if you're doing migrations from Oracle to Postgres, Duet AI will do the code conversion for you, so you don't have to do a lot of the work manually. So that's really what I wanted to quickly give you a sense of in terms of what we are doing in AI with databases. And as you can see here, the idea is that we'll make AI in databases available everywhere, whether it's on-prem, in the cloud, and any type of database engine, and to suit any type of persona, developers, DBAs, business users, DevOps, and SREs. So thank you for your attention today. Thank you for attending PGConf. Enjoy the rest of the sessions, and please visit our booth and ask any more questions that you have around AI or in general, any of the Google Cloud databases. Thank you very much.